How do satellites stay in space? If I take an apple and hold it out at arm's length and then let go, it falls. Looking at the forces between the apple and the Earth, the only force acting on it is the force of gravity, which makes the apple accelerate towards the Earth. Now let's zoom out and look at satellites high above the Earth in space, where we can do the same thing. Again, the only force acting on the satellite is the force of gravity. We can see that the relationship between Earth and the satellite is very similar to the relationship between the apple and the Earth. Notice that the satellite, same as the apple, should hurtle toward the Earth by this law until it ultimately crashes into the surface. So how do they stay in space? As a matter of fact, the moon is also attracted to the Earth, so why doesn't it fall out of the sky? Let's back up. Let's think about how we can counteract the force of gravity on Earth. One of the first things you might think of is attaching a string to the apple and then spinning it very fast. As it spins, you should feel a tension force on your hand. When switching to the apple's viewpoint, that same tension force is acting on it as well. So what makes the apple stay in motion? Why doesn't it crash into your hand? Well, the apple's velocity is changing direction as it moves, which means it's constantly accelerating towards your hand. This is caused by the inward pull from the rope. Without the pull, the apple's velocity would carry it off in a straight line instead of circling your hand. From circular motion equations, we know that the acceleration a can also be written as omega squared r. And so plugging that into the ft equation, we get Ft equals m omega squared r. Now let's zoom back out to the satellite, far above the Earth in space. We've been ignoring that satellites actually spin or orbit around the Earth, like the apple on the string. A single force is acting on an object that is spinning really fast at a certain radius from the center. We can then relate the equation of the spinning apple to the satellite. From here, we can rearrange. Notably, the satellite's mass cancels out, and so it doesn't impact its angular velocity. But angular velocity is sometimes hard to get your mind around, so converting it to period using this formula makes it much more intuitive. So what keeps satellites and the moon in space? Well, they just spin really fast around the Earth to counteract the force of gravity, just like an apple on a string.